Now we're going on to problem number 3. Describe the left-hand and right-hand behavior of each function. You don't have to do any work here at all. Nothing to be done. If you don't know what's going on, you look at the leading coefficient. It's positive, and that's an odd power function. So without doing any work, I would just do this. Because it's odd, I know the graph has to go like this. I don't care what it looks like. So we write the limit of the function as x approaches infinity. The limit of the function as x approaches negative infinity. I just want you to read the graph here. So if we're going to infinity here, what's the y value doing? The y's are going up. This is infinity. So we say it equals infinity. That's the right-hand behavior. Now we're going to the left side. As x goes to negative infinity, what's happening to y? So if you watch here, as x goes to negative infinity, it's dropping off. It's going to negative infinity. You're done. Next problem. Oh, that was quick, wasn't it? Now, that's called learning your definitions. Here is an even power function. The even power function, leading coefficient, is negative. So again, I'm just going to draw a graph. I don't care what it looks like. I know the y-intercept is -1 there. So I put -1 right there. This intercept right here was 0, so I just knew it went through 0. I should have said that, but I didn't. Because it goes through -1, we know all odd power functions behave the same way. They either go up or they go down. Leading coefficient is negative, so it just goes down, so it always does something like this. And then shoots down like that. I don't care what it's because I know it's 4th degree. I just know it goes like that. Could it look different? Yeah. But it's going to look something like that. Anyway, the limit of the function as x goes to infinity. Limit the function as x approaches negative infinity. Here you go. If I look at my graph, again, we're going to infinity. This is the x-axis going this way. What's happening to the y-axis? It's going to negative infinity, right? Because negative infinity is down here. So we say it equals negative infinity. Here, the next one says the limit of the function as it goes to negative infinity. That's the function. Remember, f at x. And they're saying f of x right there is y. What's y doing? Well, again, it's going down. It's going to negative infinity. So that's why they wanted to know end behavior. This is called end behavior. Without doing any graphing, you know right away what end behavior is. You have to know what if it's odd or an even function. How do you know if it's odd or even? You look at the exponent. Right there, the leading coefficient exponent, and right there. That's odd, that's even. Done. So as you get better at math, you'll learn how to do this stuff rather quickly. Here they want you to find the zeros. Determine the number of number of turning points. Without doing any work, we know the number of zeros. And then it says find. There are 3 zeros. How do I know that? I looked at the leading coefficient right here and the leading exponent. It's right there, 3. So I know there's 3 zeros. How many turning points? It's n minus 1. See, n here is 3, the number of zeros, the exponent, that's called n. It's 3. N minus 1, 2 turning points. 2 turning points. And I'm not used to doing videos all the time, so I have to always look up and see what I'm doing to make sure you see it. I think I'm saying something, but I might not be. But you'd be in class and yelling at me, so it's all new for us both. Now, how do we find the zeros? Well, we take x cubed minus 12x squared plus 36x, and we set it equal to 0. First rule of factoring is GCF. Take out an x. We get x squared minus 12x plus 36 equals 0. We factor x, parenthesis, 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 parenthesis. How do we get x squared? X. You should all know minus plus is minus and minus. Factors to 36 are 1, 36, 2, 18, 3, 12, 4, 9, 6, 6. So obviously, how do you get 12? Minus 6 equals 0. Set the factors equal to 0. X is 0. X minus 6 equals 0. X minus 6 equals 0. So our zeros are x equals 0, x equals 6, and x equals 6. 0 has a multiplicity, M-U-L-T, of 1, a multiplicity of 1. 6 has a multiplicity of 2, because they're a double root. I don't normally do this, but since I'm doing a video, I'm going to just sketch a quick graph of this function. Just so you know, without doing any work, you can do this. This is what the whole point of this section is. We know it goes through 0. We know it goes through 6 twice. See, this is an odd multiplicity right there. That's called odd. This is an even right there. That means it bounces there. So we know without doing any graphing or any work that the graph has to come up like this, and then it comes down, and then it bounces up. Now, remember when they said how do you graph? Well, you're testing the points to the left is 0, so you could put in like -1, -2. To the right is 0, you could put in like 1, 3, and 5. You can put them all in if you want. Then you, to the left, or excuse me, to the right of 6, you could put in like 7, 8, and so on. But you know when you put in these numbers, that thing is going to take off. So that's what I'm showing you. Just by the general degree, we know the shape of the graph. Odd functions all look the same. So if they asked you for the limit of the function, as x approaches infinity, this is infinity out here, we know it's going to infinity. The limit of the function, as x goes to negative infinity, so we're going here the way to negative infinity, what's y doing? It's going to negative infinity. That's your left hand, right hand behavior. And I'm showing this to you so you can see it rather quickly. These problems don't take all day. What we're trying to do is show you a quick way to do this stuff. And that's what the notes were all about. That's why I spent time doing them. And it says follow the 4-step method to graphing. So the first thing you want to do is find the what? Zeros. So that's what we're always going to do first. So that's what we try to do first. But before we even do that, we should have done the LC test, which is called the leading coefficient test. It's 2. It's positive. It's a third-degree function, so we already know it's going to look like that. Without doing any work, I know all that. And we find the zeros. So I said it wrong, but I did it right. There you go. Now we're going to do the zeros. So first we did leading coefficient. Second, we do the zeros. So leading coefficient just tells you what's happening, what the graph looks like. So the zeros. So we take 2x cubed minus 6x squared. Set it equal to 0. Factor out the GCF. We get 2x squared, because 2 and 6 have a 2 in common, x cubed, x squared. Then we get x minus 3. Set 2x squared equal to 0. X minus 3 equal to 0. We get x is 3 here. We get x squared equals 0 here if you divide by 2. And x is 0 is called a multiplicity of 2. That's why you have to know what multiplicities are. This is a multiplicity of 1. So we know it goes through 0 twice, so it bounces on 0, and it goes through 1, 2, 3, right there. Now we're doing the test point method. So we're going to plot a few additional points. So step 3, plot points. Isn't this great? I always do a chart XY. To the left is 0 is -1 and -2, so I might want to put -1 and -2. So if you don't know what I'm doing, I'm putting -2 there and -1 there. Then there's 1 and 2 in the middle. And after 3 is 4 and 5. Now I'm not doing them all, but I just get an idea what's going on. But you already know what's going on. You don't really have to sketch it, but this is what they want you to do. So if I take -2 here, and this is what I would do, is I would just take these points and plug them in the factored form. This is probably easier. So, well, let's try easy. 1 is always easy to work with. Let's just do 1. 1 minus 3 right there. 1 minus 3 is -2. 1 squared is 1. 1 times 2 is 2. And we put in what? 1. We got -2. -2 times 2 is 4. Negative. So when I put in here 1, 1 minus 3 was -2, just to show you the work. And then 2, 1 squared is 1, that's 2, and I got -4. That's how I did that. Now I'm going to put in -1. -1 minus 3 is -4. -1 squared is 1 times 2. That's -8. So I don't know if I really need to do -2 because this is just going to get very, very large and very, very small, and there's not enough on the graph to do it. So I'm not even going to do -2. So I'm doing a few additional points. Next, if I want to know what's happening between those 2 points, I'm going to do 2. 2 minus 3 is -1. 2 squared is 4. Times 2 is 8. That gives me -8. Let me see, is there 8 points? 1, 2, 3, 4, 5, 6, 7, 8. Looks like there is, so we can do that one. Now I take 4. 4 minus 3 is 1. 4 squared, 16, times 2 is 32. Oh my gosh. See that? 4 squared, 16, 2 is 32. So we have 32 times 1. That's 32. That's why I didn't do a lot of points. So -1 is -8. It's right down here. We already did 0. It went through the graph because it's a single. Oh, it bounces off the graph. Oh. Let me finish plotting the points because we already know the zeros there. Because that's 0 and 3. 3 is a single root. So remember multiplicity 1? This is a multiple. This is danger. Oh yeah. That's a bounce. B-O-U-N-C-E. Whenever it's even, it's a bounce. Got to know that. Then 2 is -8. It's right there. I should have done 3. That's what I didn't do. So let's try what 3 looks like. I put in 3. 3 minus 3 was, oh, we already know it's 0. Oh, jeez. Hey, look at that. Did we do one? Yeah, we did 1. Was -4. So my lazy eye got in the way. This is -4 right there. And that should have been -8. That's a mistake. So there's what you got going now. And now we got 4. No, that was 3. So we got -1. We got 0 where it bounced. And then we got 1, it's -4. We got 2 is -8. That was a mistake there. And 3 was 0. We got to do 4 is 32. That's way up yonder. So there we go. Now because we know it bounces, it goes clunk, then it comes down, and it goes shooting up back this way. That's how you get an idea what the graph looks like. And again, all the graphs look the same. See how that one looks like that way? That one went like that. And you're done. Except step 4 says draw the graph, which we did. So step 4, draw. Done. The last one. We're going to do the same thing for this problem. Now this one looks like a bear. Oh my gosh, it is a bear. So this is why somehow we went away. I must have hit something. I got to check that out. Are you guys still? Shoot. I hope you saw the last part. Anyway, I'll check the video out when I'm done. Follow the steps to graphing the following function. So, if you didn't see this, this is what we did. We plotted the points, -1, 1, 2, and 4, -8, -4, -8, and 32. And we plotted the point there. That was -1, -8. And we had 0 where it bounced, so we know it hits the graph and it comes down. We got 1 is -4 right there. And then we got 2, it's -8. Then we got 4 is 32, and then it shot off that way. The last graph is to graph this sucker right here. Remember the graphing, this is why I told you have to know how to factor. So the first thing I want to do is set this equal to 0. So I have -1/4 x squared plus 3/2 x cubed minus 9/4 x squared. We know with leading coefficient tests, in other words, we can do the limits. And I probably should have done that limit on the last problem. This is what it makes us so interesting. But we should have done limits here just so you know. So we do x goes to -infinity here, limit as x goes to +infinity here. So that was odd right there. I better just go over this. This is what you have to do. As x goes to infinity, the y is going to infinity. As x goes to -infinity, so x is going to -infinity down there, it's going to -infinity there. The leading coefficient test tells you that. So the first thing you do is look at the leading coefficient. You know it's a 4th degree equation. Leading coefficient is negative. So without doing any work, I can do the limits here as well. This is something I added in. As x goes to infinity, limit, function, x goes to -infinity. What's nice about even functions is they both go in the same direction. See, that's even, it's negative, they're both going to -infinity. Without doing any work, you know that. So that was the LC test. Step 2, we got a factor. This is what I was going to do next. Find the zeros. Same thing as factoring. You could factor out a -1/4. This should have been x to the 4th. I don't know why it says x squared. So it's a -1/4 x squared. That leaves me with x squared there. If you take a 4th out of here, you're really multiplying this by 4. 2 goes into 4 twice. That's going to be -6x squared. Why is it -6? 2 goes into 4 twice. 2 times 3 is 6. You factor out x squared, so it should have been x. My bad. So it's x to the 1st. That's why you check your work. Take a negative out of a negative, it turns to a positive. Take a fourth out, you get 9. So when you factor it, that's what it looks like. We have negative 1/4 x squared. X factors of 9 to give you 6, minus plus. 2 sets of parentheses, xx, minus minus. Has to be 3 and 3. Here we note that x minus 3 equals 0. X minus 3 equals 0. 1/4 x squared, and it's negative, equals 0. Here x is 3, x is 3, x equals 3 has a multiplicity of 2. That's a L. Here you multiply this side by 4 negative, this side by 4 negative, you get x squared equals 0. X equals 0 when you take the square root, that's a multiplicity of 2. How do we know it's a multiplicity of 2? Because that's the second degree there. So just to make my life easy, I'm going to put down here 0. We know it bounces on 0. And it also bounces at 1, 2, and 3. So we got to do points to the right and the left. So that's step 3. Step 4 is a graph. We're doing that as we go. So if I do x and y, I would choose negative 1, just to see what's going on. This is an ugly problem. So what you're doing here is you're putting in negative 1. That's negative 4. Negative 1. That's another negative 4. Negative 1 squared is 1. Times negative 4 is negative 1/4. See, that's why I wrote it out there, so I can see what's happening at negative 1. The 4's cancel. Negative times negative is positive, times the negative is negative. I get negative 4. Look at that. So at negative 1, right here, negative 1, negative 2, negative 3, negative 4. I already know what the graph looks like. The next point, if I choose negative 2, it's going to go shooting down way out here. We don't have enough room to do that. So we got 0 already. We'll take 1. Let's see what happens at 1. 1 minus 3, that's negative 2. 1 minus 3 is negative 2. 1 squared is 1, right? Yeah. Times negative 1/4 is negative 1/4. You multiply all those together, you're going to get negative 1. So I plotted the point. We know it bounces there, so that's negative 1. I'm going to put in 2. 2 minus 3 is negative 1. 2 minus 3 is negative 1. 2 squared is 4. Times negative 4th is negative 1. That's all negative 1 if you multiply them together. 3 negatives make a negative. 1 times 1 times 1. My God, those two are the same. And then we have, that's 3, so we're going to choose 4. 4 minus 3 is 1. So I better put a 4 there so you see it. 4 minus 3 is 1. 4 squared, 16. Times negative 1/4 is negative 4. So let me see. 1, 2, 3, 4. Look at that. It's following its pattern. It looks like this. Bounces off the graph there and then it shoots down. I'm not the world's greatest drawer, but there you go. So there you go. That's your lesson for today. I'll put the section 2.2 problem numbers 2.2 homework. Look at Google Classroom. Have a great day, folks. Enjoy. If you have questions, come to class prepared to ask. That's what I would tell you. Love y'all. Hope it's been good. I'm done.